So in the toy model tab, let's develop some intuition. What happens to portfolio risk and return depending on different variance and covariance between the two assets that we're mixing together. So here I'm going to start with the baseline scenario where we have Apple and gold, but we can change the parameters so that there will be different assets. We're just going to call them asset A and asset B. Let's calculate variance because we're going to need it for some of our calculations. So variance is just the standard deviation squared. We can do that here. And covariance is just the correlation coefficient times the standard deviation of asset A times the standard deviation of asset B. Let's calculate average return with different portfolios. So that's going to be the weight on asset A times the return on asset A locked plus weight on asset B, which is 1 minus the weight on asset A times the return on asset B. We're going to lock it. And let's calculate it over here. Control R, that works just fine. Let's calculate the standard deviation of these portfolio, of the returns on these different portfolios. So that will be the square root of, and we'll take the weight on asset A squared times the variance of asset A locked plus weight on asset B squared times variance of asset B locked plus 2 times weight on asset A times weight on asset B times covariance between those two locked. And we got to close the parentheses here. That's perfect. Let's copy that all the way down. We'll do Control R. Perfect. And so this is actually the same opportunity set that we saw with Apple and gold, because I just copied these parameters. These are the returns and standard deviations and correlation between Apple and gold. But here we can change it. For example, we can see what happens if correlation coefficient between those two is 1. If there's one, if the correlation is 1, which means they move perfectly together, there really are no diversification benefits from mixing those two assets. Whichever asset you want, you either pick, if you don't like risk, you're going to pick this point here. If you like risk, or if you like returns more than you like risk, you're going to pick this point. But with one-to-one correlation, there's no curvature in the opportunity set. However, if the correlation is 0, let's see what happens. There, some diversification benefit. We can see that the opportunity set moves up and to the left, which is awesome. If the correlation coefficient goes to, say, negative 0.5, it moves even more. If it moves to full negative 1, then we can actually achieve pretty decent return, 1.5% per month with 0% risk. So clearly, the covariance, the correlation coefficient, how these assets move together drives very much the opportunity set, and it will drive the Sharpe ratio of the maximum Sharpe ratio of the tangency portfolio. And we clearly want to combine assets. Whatever asset we have, we want to combine it with an asset that is negatively correlated. So let's go back. Maybe we can keep it at 0. But here's a homework. I'm asking, suppose we have an asset A, but now we're considering adding asset B. Would you rather have asset B with 5% and correlation 0.5, or 10% with correlation of negative 0.5? So essentially here, I would like you to do this for homework, but I'm actually going to do it. But you may want to stop the video and try to do it yourself to see what happens. And this is going to be a lot of retyping. Basically, we need to calculate returns. We need to calculate standard deviation. So let me actually just jump into the file where I have all of this calculated. So let's do it. I think it's in here. These are the calculations, the same thing we did above, but I actually put together, I think, a pretty nice graph that summarizes the nature of these different portfolios. So in blue, what we have is a combination of asset A with an asset B that by itself has a pretty low risk. However, it has a correlation coefficient with asset A of 0.5. So it's the blue line. So this is a low individual risk of asset B, but it still moves together with asset A. In the orange line, what we've got is individual risk is really high. Right? If I buy only asset B, I have a pretty low return, really high risk. But there's something really nice about the asset B, and that is it moves negatively with asset A. And if it moves negatively with asset A, look at this. We get this really big diversification benefit, really big move up and to the left. And certainly for pretty much any risk-free return, we're going to do better with an asset B that moves negatively than with an asset B that moves positively. So clearly we prefer this version, this orange version, because that's an opportunity set that is higher up and to the left. This is related to the discussion of idiosyncratic versus systematic risk, as you saw in the textbook, and we'll talk about that in class on Monday. Essentially, here asset B has a very low idiosyncratic risk, but pretty high systematic risk. Systematic risk is because it moves with the overall market. If we consider asset A to be the overall market, something that we already hold, if we already hold a diversified portfolio. Here, asset B has a high systematic risk. We don't like that. We don't like systematic risk because it cannot be diversified, right? This 10% here in this version, I should probably have called it like asset C. The asset has a high idiosyncratic risk, but we don't really care. What we care about is the systematic risk, and the systematic risk is really, really low. Okay, so I'll stop here. In the next tab, we're going to actually calculate a way of summarizing that systematic risk, and we're going to call that measure of systematic risk beta. And I have to go and watch Succession.